Now to explain the concept of hashing, we take one example which is ideal hashing example. Why I am saying ideal, I will explain. So in the example, we are using the pairs of key and the value. The pairs are 22, A, 33, C, 3, D, 72, 9, 85, F. So that are key and values. Pairs in the hash table, HT is hash table of 0 to 7 means we are having 0 to 7 total 8 positions, and in the 8 positions we just have to store the data that we have in this ideal hashing example, where m is the number of positions in the hash table. So we have total 8 positions, 1 2 3 4 5 6 7 8. 0 to 7 are the location, and we are having total 8 positions where we store these elements. Now elements are less than the positions. Elements are 5 with key and the value, and positions are 8. Now we are storing it with the hash function. Different hash functions are there. We are using that hash function so that we can store the data that we have in the example without any overlapping. So there is no any overlapping of or collision in this example. Because of that, it is a ideal hashing example. So now here we are using hash function. So this is your hash function, that is h is k mod m is equal to k mod et. Now we have the key, we have m, that is the number of positions in the hash table, and now we calculate this value, that is key mod position, and what is the result of this function. At that particular position we store the value. Suppose let us take the example of the first pair that we have of key and the value, that is 22, A. Now 22 is the key, right? So I'm writing here, that is k is equal to 22, and it's been mod by 8. So 22 mod 8, that is equal to 6. You calculate and you verify this value, and as the mod of these two values are 6, because of that we can store the data at 6th position. Similarly for the next value, that is 33, C. Again 33 mod 8, is 3. 33 mod 8 is 1. And because of that we store the value in the first position. In this manner, we are storing all these values without overlapping, without collision in this complete space or table that we have. So this is the hashing example. In this, with the help of using one hash function, we can systematically store all the values here without any collision. Now, what are the different hashing function methods? Because we have to calculate the hash function, so for that different hash methods are available and we can use that different hash methods. So here we discuss two methods, that is division hash method and folding method. So division hash method that we used in the previous example to calculate the hash function. Division hash method, in this case, the key is divided by some number m and the remainder is used as the hash address of key. That is, h of k is equal to k mod m. This gives indexes in the range 0 to m minus 1. So the hash table should be of size m. This is an example of uniform hash function if value of an m will be chosen carefully. Generally, a prime number is the best choice, which will spread keys evenly. A uniform hash function is designed to distribute the keys roughly evenly into available positions within array or hash table. So by taking a division hash method, you can calculate the positions to store the key comma value for every hash function. Next method we are using is hashing function methods. For this, the folding method is used. Now, what is the use of this folding method, or how it differentiates from division hash method of the hashing function? The key is partitioned into number of parts, comma, each of which has the same length as required address with the possible exception of the last part. Now you can understand with the help of example. So key is partitioned into number of parts so that each of which having the same length. And then these parts are added together while ignoring final carry to form the address. To understand this completely, we take the example. Here we are using a key. Now the key is 356942781. Now this key is partitioned into same length of a numbers, and these numbers are added together to form an address where we are storing that key by ignoring the final carry. Now to understand this, there is one key. Now this key, it partitioned into three parts, that is P1, P2, P3 of same length. P1 356, P2 again 942, P3 781. Partition of a key. Now these three key added together, and by ignoring the final carry, you just calculate the addition. You yield this address of 079 by ignoring the carry. So this is also one kind of a folding method that you can use in the hashing example. Now we discuss here what is collusion handling technique, or what is collusion. So in the previous slide we take an ideal example to understand hashing. Because of that we not came across any collusion of a data. Now what is collusion? Collusion means the chance of inserting more than one element at a single position, and that single position we found or we calculate by using different hash methods. So it is not the the chance that we can store two values at the same position, because it creates a confusion. Key can be uniquely identified. Because of that, one position is reserved for only one key element. So we cannot store more than one element in a single position. And if such type of collision is occur, then what is the solution for this? So for that we need to study, understand what are the different collision handling techniques, that if and whenever collision occurs, you can use the methods which are associated with collision handling technique. So the most two popular methods of resolving collision are open addressing and second is chaining. So first we consider what is open addressing. Collision resolution by open addressing, in that once a collision takes place upon addressing or closed hashing, open addressing is also called as closed hashing, computes new position using a probe sequence. Now we are using here probe sequence. So with the help of example you can understand this, what is probe sequence. And the next record is stored in that position. The hash table contains two types of values. The first value is a signature values, for example -1, and data values. So to understand this, we are using one method called linear probing, which is a sub part of open addressing, or inside the open addressing we are using one method, that is linear probing. And to understand linear probing, we take one example so that we come across or we can understand what is open addressing. So now, before understand or before start with the actual example which explains open addressing, first of all we have to understand what is linear probing, which is a sub part of, or which is a sub technique of open addressing. So in the case of linear probing, if a value is already stored at a location generated by a hash table of a key, then the following hash function is used. If a value is already stored with the key, right? So for that we are using this hash function, that is h of k comma I is equal to h dash of k plus I mod m. Now what is all these values? So where m is the size of the hash table, what is the size? Total size of the hash table. H dash of k is equal to k mod m. So by using division method, we can calculate h dash of k. I is the probe number that is varies from 0 to m minus 1. Therefore, for a given key, first the location generated by h of k mod m is probed because for the first time I is equal to 0. Now this is a probe number. Initially I is equal to 0. If the location is free, if that particular location is free where we want to store the key, then I is equal to 0 and the value is stored in it. Else the second probe generates. If the place is not free, then second probe is generated because we want to store the key at a unique location. So second probe generates the address of the location given by h dash of k plus 1 mod m. H dash of k plus 1 mod m. Similarly, if the location is occupied, then subsequent probe generate the address as h dash of k plus 2 mod m, comma h dash of k plus 3 mod m, comma h dash of k plus 4 mod m, and so on. So probe number increased as up until we cannot get the free space to store that data, because here the ultimate aim is to remove collision. So we can uniquely identify each record. For that we are using a key for particular number. Now this is the example. Now consider the hash table. Now see, in this example, it is not possible at this stage to completely explain the example from start to end, but here I am in a position to explain at least Whenever collision is occur, how to solve with the help of linear probing. So I have only tried to capture this part so that you understand the concept, and once you understand the concept you can easily solve the questions, the example based on linear probing. So here we'll take a hash table of size 10, means locations are from 0 to 9. Using linear probing, insert the keys. Now we are inserting the keys 72, 27, 36, 24, 63, 81, 92, and 101 into the table. Let h dash of k is equal to k mod m and m is equal to 10. So initially the hash table is given as in this format with sanital values, that is -1, till we not inserting the key value. It's showing as a -1 in all the locations. Once you enter the value, -1 is deleted from that, and with the help of -1 we can understand that there is a chance of inserting the data into that hash table. So step 1, consider first element, that is 72. Key is equal to 72. Hash table of key, that is 72, 0. 0 is probe number. Initially it is 0. Now 72 mod 10. 10 is the positions plus 0 mod 10. So 2 mod 10 is equal to 2. Now since t of 2, hash table of second position is vacant, insert the 72 at this location. So here we insert 72 at location 2 as we calculate the value by using the formula. Understand? This is for first element. Similarly, you can find out the position for all the elements that are there in the table. Now the question is where collision is. So the collision is in the next slide. Now here I am continuously adding the element inside the hash table. This is the hash table, and as we come across a different steps, we are reaching to the step number 7. At this step number 7 you can understand that how linear probing helps to remove collision in the hash table. So consider the key is equal to 92, and with the help of mathematical formula that we apply, we calculate the position, that is 2. Means at the second position, now we want to insert key 92. But as you see the hash table, the second position in the hash table is already occupied in the step 1 itself. So now there is a collision, because at the same position we just want to insert 2 values. Now what is the solution for that? Now t of 2 is occupied, so we cannot store the key 92 in t of 2. Therefore, try again for next location. Thus, probe, I is equal to 1. So probe value is I is equal to 1 this time. Now again key is equal to 92. H of 92 comma 1. Now H of key comma probe number, which is 0 in the previous case, now it is 1 because the second position in the hash table is already occupied, and according to that the answer is change. Now 92 mod 10 plus 1 mod 10. So the answer is 3. Now we search for T of 3. Now T of 3 is also occupied, so we cannot store the key 92 in T of 3. Therefore, try again for the next location. Now probe number is I equal to 2. Key is equal to 92. Then again we calculate by using the same method, only by changing the probe number. After doing this, again T of 4 is also occupied, as 4 is the answer for the previous probe number, that is 2. Now again probe number is incremented by 1, that is 3. Now this time key is equal to 92. H of 92 comma 3, that is we get the answer is 5. Now in the hash table we see that T of 5 is vacant. It is not occupied by any key value. So now there is a chance to add 92 at 5th position. So by doing all these mathematical manipulations, by changing the probe number for every time, we can successfully find out the unique position to store the key value for with the linear probing. So this is one type of a method. With the help of that, you can just minimize or delete the collision from the hash table. Next collision handling technique in the hashing is chaining. Now what is chaining? In chaining, each location in hash table stores a pointer to a linked list that contains all the key values that were hashed to that location. So if you go through the slides of linear probing and hashing it as well, you can understand this very quickly, because here we are providing a pointer where collision occurs, we are using or we are creating a linked list over there. So again collision deleted. So as you observe the figure, it shows the key values are mapped to the location in the hash table and stored in a linked list that corresponds to that location. So observe the figure so you can understand in which manner or in which way you can use the linked list concept in a hashing or in a chaining to avoid the collision. Chained hash table with the linked list are widely used due to simplicity of the algorithm to insert, delete and search a key. So in a simple manner, like we are doing in the single linked list, the same code we are using here also to insert, delete and search any element from the hash table. Chaining method, we take one example, and with the help of this example we directly understand how we are using this chaining method successfully to avoid the collision or to delete the collision in the hash table. Now insert the keys 7, 24, 18, 52, 36, 54 and 11 and 23 in a chained hash table of 9 memory location. For that we are using h of k is equal to k mod m. This is a hash function h of k, hash function of k. To calculate the key, we are using the method that is k mod m, where m is the position that we are given in the example itself and k is the key. So in a step 1, the key is equal to 7, h of k, that is 7 mod 9, position 9, 7 mod m is equal to 7. So here we are taken a linked list. Initially this linked list is empty. As we get the position to store the key, that is 7, because of that we create a linked list for location 7 and store the key value in it as its only node. Similarly for key 24, we got the position 6 in the hash table, so we store it at location 6, the 24 key comma value, that is null. Now the next step, in the step 3 and 4, next key value, that is 18 and 52. Now 18 mod 9 is equal to 0. So the key 18 is stored at the 0th position. In the step number 4, we got the value 52 key value, and for that 52 key value we got the position after calculation, that is 7. Now in the 7, in the previous step number 1, we already using this location, so we create a pointer. So in the next part of the first linked list, we have the address of this data. So by fetching that address, we store the next element. So there is no collision. It stores at different address, it stores at different address. And similar manner, we are creating a linked list. Now observe the next step. With this example, we can completely store, insert all the values at particular position. Now next key is 36. Now 36, again we get the same value, that is same position, that is 0 here. So 0 is already occupied. Now this 18 having the address in the next part, with the help of that it can point to the next element that is linked with this first element. because both having the position 0. Now in the step number 6, the key value is 54 and 54 insert at the end of the linked list of location, because we got 3 times 0 as an answer for this hash function, and for this we are creating a linked list, and we are creating a successfully linked list because we are using the pointer and we are storing the values one by one. Now in the step number 8 and in the step number 7, we only remaining with the two values, key values, that is 11 and 23, having the positions as 2 and 5 respectively. 2 is not occupied previously, so we are systematically insert key 11 in the second location. And in the similar manner, 5th is also not occupied at all, so we are putting it at the 5th location. So in this manner, we systematically, without any collision, by using a chaining method, we store all the values inside the hash table using singly linked list. In this similar manner also, you can delete the data, you can search for any element. So as you understand the concept, you just try to solve a different example which based on linear probing, which based on chaining. So these are the very systematic way to store the element without any collision, without any confusion inside the hash table. Thank you.